Okay, so I went and had supper and I kind of forgot where I was, but let's assume that I've given you the radius and the diameter. And now what I need to do is get the area. So pi, r is 0.0295. Don't forget to square it. So when I did that math, I got the area to be 2.73 times 10 to the minus 3 meters squared. So there's my area. Now what they want to know is if I take an aluminum pipe and a copper pipe and add them together, what's their total resistance? Well, R for the aluminum, oops, that was kind of funny, is equal to, ooh, don't tell me mistaken, rho L over A. Well, you have to look up rho. Well, I got on the internet, and I find out that rho for aluminum is 2.75 times 10 to the minus 8 ohms times meters. The L, the length of the aluminum wire, tells me right here, 0.85 meters. And the area is 2.73 times 10 to the minus 3 meters squared. So the resistance of aluminum by itself, I got 8.56 times 10 to the minus 6 ohms. Now I need to do copper. So the resistance of copper is rho L over A. Rho for copper I looked up and it's 1.69 times 10 to the minus 8 ohm meters. The length of this wire is 1.3 meters. Area is still 2.73 times 10 to the minus 3 meters squared. So the resistance for the copper, I got it to be 8 times 10 to the minus 6 ohms. So I'm going to take this and I'm going to add it to that. And I'm going to get 16.56 times 10 to the minus 6 ohms. But easier to write is 1.7 times 10 to the minus 7. 10 to the minus 5 would be a better number. Ohms. So there's the resistance for my two wires that are joined together, or my bars, however you want to express it. So that was number 5. Alright, so then we go on and we look at number 6. And we know that number 6 has a power of 7.5 watts and that the resistance is 75 ohms. Oh, can't believe I did that. I should have said R is equal to 75 ohms. That was kind of goofy. Here we go. So I want the voltage. So I said power is equal to V squared over R. So V is equal to the square root of P over R. P is my 7.5 watts. My R is 75 ohms. I take the square root of that and I get V. And I got V to be this is kind of looking suspicious. Power is equal to V squared over R. Yeah, you got to be able to do some math every now and then, Miss Walker. So let's take a look at it. So power times R square rooted is V. So if you do this correctly, which I did not do, then you get 7.5 watts times 75 ohms. And so that gives me the voltage, when it's done correctly, of 23.72 volts. And again, my apologies. Then the next question says how much current? Well, I is equal to V over R. V is 23.72 volts. R is 75 ohms. So if I can divide correctly, 23.72 by 75, I get 0.32 amps. And then the next thing is it's going to run for 90 seconds, so Q is equal to IT. So 0.32 amps times 90 seconds Well, that's going to give me about a third of 90, or 28.5 coulombs. And then they want to know, how many electrons is that? Well, that's a dimensional analysis, 28.5 coulombs. And, man, that looks terrible. Let's fix that. 28.5 coulombs. Each electron, 1.6 times 10 to the negative 19th coulombs. So if I make that division occur, I got 1.78 times 10 to the 20th electrons. There we go. All right, clear that off. Let's go on to that big old fat resistor one down there. Not a big deal. I'm asked to find B and I for each of those resistors, and there are 13 of them. So I see immediately, oops, parallel. 1 over 6, 1 over 3. So RT is 2 ohms. Replace that with the 2 ohm resistor. 1 over 15, 1 over 15, 10 and 5 is 15, another 15 there. RT is 5 ohms. So that whole group is worth 5 ohms. So now I have a 1, a 2, a 4, a 5, a 12, a 4, 10, 8, and 2. So RT is just the sum of all those. So 1 plus 2 is 3, plus 4 is 7, 7 and 5 is 12, 24, 28, 38, 48. So there's RT. So now I'm going to go back and try to figure out all my currents and my voltages, because it's going to be a piece of cake now. Well, I know that IT is equal to VT over RT. So that's 96 volts over 48 ohms, or 2 amps. So that tells me that I1, which is the same as I4, which is the same as I9, which is the same as I10, which is the same as I11, which is the same as I12, and the same as I13. All of those are going to be 2 amps, because they're all in series. And in the series circuit, we know the current is the same. So out here, I have 2 amps going through 2 ohms. So that means there's 4 volts here and 4 volts here, because in a parallel, the voltage is the same. 2 amps going through 5 ohms, 10 volts, 10 volts, and these are going to add up to 10 volts. Okay, so I've got all my I's. Now let's go back and get I2. 4 over 6, 2/3 of an amp. I3, 4 over 3, 4/3 of an amp. I5 is equal to I6, which is 10 over 15, which is 2/3 of an amp. Okay, I7 is equal to the total voltage of 10 divided by the total resistance of 15, 2/3 of an amp. So I've taken care of all my currents. Now let's go back and look at our voltages. V1 is 2 amps times 1 ohm equals 2 volts. V2 and V3 are equal, and they are 4 volts. V4 is 2 amps times 4 ohms is 8 volts. V5 equal to V6, 10 volts. V7 is 2/3 of an amp times 10 ohms, which is 6 2/3 volts. V8, let's change colors, is 2/3 of an amp times 5 ohms, which is 3 1/3 volts. Oh. Now, this one and this one have to add up to 10, and they do, so yippee skippy, I get a big old check. And then I go on and I look at V9, 2 amps times 12 ohms, 24 volts. V10, 2 amps times 4 ohms, 8 volts. V11, 2 amps times 10 ohms, 20 volts. V12, 2 amps times 8 ohms, is 16 volts. And V13 is 2 amps times 2 ohms, 4 volts. Now, theoretically, everything should add up to 96. So I'm going to check. That's 2 volts. This group is 4 volts. This group is 8 volts. This group is 10 volts. That whole group is 10 volts. 24 volts. 8 volts. 20 volts. 16 volts. And 4 volts. So let's see. 6 and 8 is 14. 24, 48. 48 and 28 is 76. That's 92, and 4 more is 96. Yeah, buddy, we got it.